Number 9 asked us to find a second derivative, which is not something we explicitly talked about in school, but was in Delta Math and flows fairly intuitively from a first derivative, right? Take a derivative, then do it again. So y double prime is just saying, let's take the second derivative of y. This could also be expressed as in this format here. All right, so let's go ahead. And first, we need y prime, or our first derivative. So y prime, or our first derivative of y with respect to x, we need to recognize here, this x squared is the exponent here in our exponential, our e to the x squared. So this is technically a chain rule. The outside function is e to the, and our inside function is x squared. So we have to recognize that if we're taking the derivative here, we're going to have our outside function, keep the inside function the same. Oof. Filling in when my pen doesn't work is always annoying. Times the derivative of my inside function. So this is going to be 2x e to the x squared. All right? So when it's time to take our second derivative, and the reason why the little 2 goes in the second area of this here is because we are taking a derivative with respect to x twice. So if you really wanted to write this down, we're taking, the derivative with respect to x of this first derivative. You'll notice there are 2 dx's here, but there's only 1 dy, so that's why we end up with the squares ending up, or this little, like, I wouldn't even call them squares, but this second notation sort of ending up in different spots. So anyways, let's take our derivative. We need to recognize that now we are in product and chain land, right? We have that same function we had before, but now it's times the 2x. So let's just go ahead. We'll write it slow. We'll move slowly. Derivative of the first times the second plus this first. Come on. I'm not liking how that looks. Times the derivative of the second. All right, so let's go ahead. I'm going to highlight those so we can see the different pieces. All right, and then we can take our derivatives in that last step as we're finishing. So derivative of 2x is just 2 e to the x squared plus 2x. And then here we're going to end up with the same thing we ended up with before. We already took the derivative of e to the x squared once. So we can just bring that all down. It's 2x e to the x squared, right? This is just the same thing we had there. So if you want to be cute about it, our final answer might look like this. There she is. There's our second derivative. Nothing told you had to simplify to make it beautiful, but there's your y double prime. Given that original, come on. Write anywhere, pen. You know there's a double prime there, y'all. It's right here. And I hope you can see my dots. I'm getting mad at this. Well, I will maybe just erase it. Okay, I'll just put an equal. That's fine. Y double prime is equal to all that nonsense that we just found. A most common mistake on this was treating it differently in terms of our chain rule. Treating this as e to the x squared. Remember that one day in class that we had that really horrible worksheet and everyone hated me? Where our exponent is touching is what it applies to. It is not, there are no parentheses here. So this is not e to the x squared. This is e to the x squared, right? Like the square is only touching the x. So this is totally different than having what we have here, which would be equal to e to the 2x because of exponent rules, which would be a totally different and much easier problem. So just sort of recognize that whatever your exponent is touching, that is the only thing it applies to. So in this case, it only applies to the x. It is not an e to the x squared. Now, if you wanted to be clearer about this as a math student, you could put parentheses there so that everyone knew. Math people are not that good at communicating, so we tend not to do that, and our stuff will be harder. So you always need to think about what does that exponent apply to and be very careful.